Hi everyone, this is Richard Carlton. I'm here today with Mr. Nick Lightbody from the UK. Hey Nick.
Hi Richard, good to speak with you again.
In this exciting installment of our video course, we are talking about the upgrades to the FileMaker Server 15 product, right?
Correct. It's a great time to be talking about FileMaker again now with a great new product out there, and we're looking forward to seeing everyone using it, I guess, because it's going to be a significant improvement on 14, not a vast improvement, not a thing that people are going to notice lots of whizzy new bangs and features, but it's a good, solid, incremental, improved performance product.
And then this conversation is based upon a benchmarking tool that you've created, Nick. So can you give us an update on how your benchmarking tool has been improved or changed, or what's going on with that?
Okay, cool. Yeah, we released the benchmarking tool at the .fm private or free conference in Berlin last May or June, and we put it out there as an open source product, so both people could use it as a benchmark, but also as an exemplar for high performance FileMaker engineering. Since that time, we've had a lot of interest around the world, a lot of developers using it. FileMaker seem to be using it themselves as well some of the time, and we've had a Chinese translation done, and we've got Spanish and French translations in preparation at the moment. So it is aiming to be available around the world for everyone who wants to do some benchmark testing on FileMaker Server.
Well, that's very cool. And if we want to get a copy of this benchmarking tool, where do we find that?
You can go to the downloads page on despace.com. You can go to Richard Carlton's starter kits page. I'm sure you can put the link in for that, Richard. So it's commonly available. It's a freebie. It's open source. The only thing you have to do when you first use it is agree to the license once, and thereafter you can do whatever you want with it.
Cool. Well, considering that we had a pretty good improvement in performance from 13 to 14, how are we looking with the 15 release?
The 15 release seems to handle high loads more gracefully than did 14. In the previous video, we looked quite hard at how FileMaker Server chokes, as any database server will. If you put any database server under enough load, then it will choke, and we analysed how that worked. And there are two parts to choking. The first is when it chokes. The second part is how long it takes to sort itself out and get going again. And the impression we have from the testing we've done is that 15 is more able in that area, so that by sorting out things more quickly, if it is ever pushed to the limit, you're going to see it coming back up again significantly more quickly.
So important to understand, and we covered this in the previous conversation, is that if you look at the performance monitor on a FileMaker server, it can be deceptive. And deceptive in the fact that you have 10 or 20 or 30 users or whatever it is, and the server is showing that it's using like 5 or 10% of its processor, and it's really lightly loaded. And so, of course, you think to yourself, well, if 10% gives me 30 people, then I can, quadruple that number, and I'll be using 30 or 40% of the processor. And it's misleading, and Nick and I have charted this previously, and you can see that right here on screen, where everything is going along just fine, and then suddenly FileMaker hits this peak or plateau, or it hits this critical spot where it's not able to handle the traffic gracefully. And so it goes very quickly from loafing, where it's not trying very hard, or it seems it's not trying very hard, to where it's choking under the load, and there is a significant measurable delay in what the clients are seeing as they access the database.
For sure. And the performance, the characteristics of this condition are best thought of, I suggest, as binary. Either it's happy or it's not. And in consequence, the way you've got to think about it, I think, is this, that if it's handling the traffic gracefully, then it's handling it and everything gets done and there's no problem. There's never a backlog, basically. But the moment that some loading occurs, something occurs that results in a backlog building up, that backlog then chokes the whole thing. And it's like any flows of cars on a freeway, flows of water down a drain, any type of flow. A server is dealing with a flow of data, and when it's smooth, but the moment you start interrupting it, that's when the problems occur.
That's a really good analogy. Once you have an accident on the freeway, or it slows down a little bit, then it starts to back up, and then even if you release the blockage, whatever that was, say that you have, your server's good to 50 users, for example, and you add 51 users, and it starts to you start to have a backlog. The freeway starts to slow down. If you remove 4 or 5 of those users, it's not instantaneously fixed. The freeway takes a while for it to clear itself, right? And I think you've shown that.
And that's right, because when you take it down to the small bits, the reason it doesn't clear itself immediately is that every vehicle has got a response time, and every driver has to decide that it's safe to start going forward a bit and vary the speed accordingly. When you look at the data going through the server is dealing with a whole series of instructions. Every instruction is like a car on the freeway, and each instruction has to be handled. It has, although these things are almost instantaneous in normal circumstances, if there are an awful lot of them happening together, this all builds up, and so you get that lag. It is worth pointing out, of course, that FileMaker Server, like any database server, is going to always work better on a hardware setup which has got really fast I/O. That's in, out, or read-write. It's the time that it takes to handle the recording and reading of data, which is also quite an important factor in this particular situation.
Yeah, so we're talking about I/O for the most part. You're talking about 2 parts of the computer, but for the most part, it's the type of drive, or the kind of drive, or the quality of hard drive that's on there. And then also the bus speed. And then we're getting technical here, but just suffice to say that it's the pipe that connects the processor to the hard drive has to be robust. And you can get into an older machine that doesn't have quite such a robust, little freeway there between the processor and the hard drive. So, of course, that's what we're testing here. This testing is pretty interesting right here. Can you tell us about what we're doing right now?
Okay. On the graph, which is indeed a FileMaker chart, this is in the app itself. I'll just make it a bit bigger here. And in fact, it's a really nice use of a FileMaker chart as well. So that's dynamically being written. And there are 3 lines on it. The very bottom line that currently is absolutely bang on the bottom of the graph is a red line called DQ. The line above that is the period line, which is the green one. And the line that you can see going diagonally up the screen is the number of users. So currently, it's on about 115 simultaneous users. Each of these users is in fact an independent server-side script, and because every server-side script is handled by a FileMaker Server as a separate and unique user session, it means that those scripts can be sent off into server to run autonomously until such time as they get closed down. And at the moment, because the machine is running very happily, you can see that the numbers of users are increasing on quite a straight line, quite a steady line, and the program on my machine here is just sending out a new user about every few seconds, and each of those users has got a cycle of jobs they're doing where they're creating a record, writing to a record, committing and saving it, waiting a bit, and then doing the same thing again. So with, for example, 125 users as you've got at the moment, you've got jobs being created and written the whole time, and the rate of record production on this is probably about 1 per second.
So the question I have here is that these simulated kind of robot users that are on there, are they continuously doing finds and sorts and adding new records and deleting records, or that you said they take a little bit of a pause to simulate what a real person might do? Yeah. How much pause is in there?
We've got 3 different types of user: intense, busy, and fairly inactive. And the intense users have I think from memory, about a 5-second pause. The busy users have from memory again, it's a 20 or 25 second pause, and the fairly inactive one's about a 90-second pause. But these users are not doing sorts, they're not doing deletes, they're only doing record creation. What we're trying to do here is to create a consistent way of comparing the performance of one server deployment with another. And the conclusion I came to a couple of years ago was, having looked at the various loads on these things, the biggest loads on server are record creation and deletion. And in order to do something sensible, it seemed to me that the best way to deal with it was just to make lots of records. As I said, the app is open source. If somebody wants to take it in hand and start adding some new stuff to it, they're very welcome. I just ask that if they do that, they do share it with the rest of the community and benefit us all.
Now, on this graph, lines at the bottom, I mean, I understand the users, but the red line and the green line, can you clarify those for us?
If you look carefully down the bottom corner here where my pointer is, you can see the green lines are starting just to pop off the bottom a little bit. So the green line is the period. And on the right-hand side of the graph, the vertical axis, the number 10 is 10 users, but it's also 1 second to complete a job. Okay? So the job time, that's to say the record creation, essentially the setting of some random text into the field in the record, and then the committing and saving of it, that's taking currently about 0.3 of a second. If you look very carefully, bottom right hand corner, you can see here there's a little peak appeared as the load's increasing. If you go back along the graph to the left here, you can see the green line is almost invisible back here. Gradually you're seeing a few little peaks coming up. So that's the green line, is how long it's taking. Just see another little slightly bigger peak now down here. Now the dequeuing line is the red line. This is a function in the software that comes in when the performance falls to a certain point. Then it seeks to pause what's happening to give the server a chance to get back on top of things. So we're actually trying to help server out a bit here. And the effect of that is that nothing happens with the red line until the thing really comes to be under a lot of load.
So let me ask the question. So the DQ, does that mean that the existing users continue to do what they're doing and we're not adding new users? Or does that mean that we're not adding new users and the existing users are all trying to pause?
No. What we're doing with dequeuing is any new users, because we're continuously creating new users here, as long as the current response time is good, that goes ahead straight away. If the current response time is, or the performance is falling, then we put the new user into a loop and they don't go forward and start doing their work until the performance is recovered. So we're trying to take the load off the server by that mechanism.
Okay, and so the question I have is then the existing, say like user number 100 and user number 80 that are on this chart, they're continuing to hammer away at full speed, correct? So we're slowing down or pausing what the new users are doing.
Exactly. What we're doing is we're taking our foot off the gas in terms of adding new users. So the load never reduces, but the dequeuing is to pause in applying additional load.
So to be clear with everyone, this graph does not mean that the server that you have is going to support 200 users. We need to be very clear about that. This chart, and we mentioned this in the previous video when we were talking about 13 and 14, we first introduced this. This is more about having a comparison between server setup A and server setup B, where server setup B has maybe more processors and more RAM and maybe a solid state drive or something like that, right? So
I think the clue is in the name, isn't it, Richard? So DS benchmark, it's a way of providing a consistent test across different deployments. The way that you can use it to estimate real-world users is as follows. Take your existing system that you know has a certain capacity but that you suspect is near its limit based on hard experience. Run DS benchmark on that deployment and see what numbers you get for it, what the maximum load it can take. So if, for example, your existing system happy with 50 users and not so happy with 65 users, you run this on it and it goes to, say, 200, then you've got a comparison, haven't you? So if you then install DS Benchmark and run it on some proposed, say, cloud service you're going to use, and it goes to 400 and it goes to 200 on your existing deployment, then you've got at least a basis for thinking that perhaps the proposed cloud service will have about twice the capacity.
Seems to be motoring on pretty well in general, although obviously the period or delay there is starting to be more measurable.
Actually, another interesting thing on the side is the way in which FileMaker Server Admin Console deals with load. I'm currently not sure if there's much of a difference between 15 and 14, but certainly with 14, when you really start loading the server, the console becomes virtually completely unresponsive. Okay, there's the first little bit of red, bottom right-hand corner now. I need the magnifying glass here, don't we? I'll tell you what though, it's one of the really cool things with this is running it on your iPhone with FileMaker Go, so that it'll happily reconnect whenever it loses a network connection. Last year when I was doing this stuff originally, I was on a train somewhere. I just had my iPhone and I was sitting testing various servers with it and going along the train, watching a little graph going along, and it was just really, really nice to do. And to be honest, it's the only time I've actually found, for my purposes, really useful use of FileMaker Server FileMaker charting actually. The only problem with the charting is there seems to be, I don't know what the number is, but there seems to be a maximum number of records it can actually cope with. So if you leave these things running on a long-term basis, the chart just stops. It doesn't seem to move on. Another thing actually is that, as a general point, that FileMaker Server Admin is still missing, in my view, one really, really important control, and that control is the control that enables you to reset the statistics. Let's just let this run because it's getting to the point now where it'll choke. And you can see also that the pauses, the responsiveness of the chart itself starts falling off a bit as it gets. So you can see the dequeuing is occurring there. You can also see, if you look carefully at the green line, so the green line is heading up towards 3 seconds. Now, on my analysis, 3 seconds is the maximum length of acceptable performance time. There we are, it's actually peaked and gone down. So what's happened there is that when the performance over an average of, I think it's going to be about 5 events, when that performance, the average goes to 6 seconds, it automatically cuts out. And you can see now that the performance, that the loading rather, is dropping as the app automatically is terminating the remote sessions. You can also see, obviously, a lot of dequeuing happening because the whole thing is in a state of considerable unhappiness. But the important thing is that in a short while, the number of users will have dropped back to 0, and if we then start the test again, it'll start again happily. And the period it's taken to go from the peak and then recover is quite quick. I'm not sure how long it is, probably a bit over a minute, maybe a minute and a half. It's closed down. I think we'll find there are no users left. So if we now start it again, and perhaps start intense, and then we'll see some new ones going. So you can see that it closed it all down.
Okay, it closed it all down. The server, well, your app did, correct?
Our app is designed so that for every cycle that each remote session is doing, it has to do a little check-in in the cycle, and if we put a stop in that point, a stop code in that point, then it'll actually cease its activities. So that's how we actually deal with this sort of situation. We load it up until the performance becomes non-performant, which is over 3 seconds, but when the average gets to 6 seconds, it's dead as far as we're concerned. So and you can see on the graph here, Can you see the green line sort of goes up and then shoots straight down again? So basically, it caught it on 6 seconds, immediately closed everything down, and takes the load off. And what that means is, when you're doing this as a thing, and you obviously need to do the same test several times on a deployment to see, get consistent results. You can then put that up, take that graph, print it out. The app makes a PDF and saves the data set for you. So you take the PDF, you put your ruler on it, you put a line through and say, okay, this is where we reckon it ceases to be performant. That's the number of users. That's the result of that test. And then you can go and do some more stuff and run it again and compare
it. Can you show us the chart comparison between Server 15 and Server 14? Because I think that's where it's going to be really interesting.
Okay, on the left of the screen, we've got FileMaker Server 14 with FileMaker Advanced 14, 2 GB of cache, busy users. And on the right, we've got FileMaker Server 15, FileMaker Advanced 15 with 2 GB of cache, busy users. So these are both the same. And the first thing you can see that on the left with FileMaker Server 14, the green line, which is how long it takes to do something, extends a mile up the chart. And because the chart's automatically scaled, it's made the main graph down the bottom here look rather flat. But the numbers are very similar. If you look at the red line across, it's about just over 350. And if you look at the red line on the right-hand side, for 15, it's almost the same spot. It's 350, or just under 360. The key thing here is that the time that 15 recovers is far quicker, in my experience, than the time that 14 takes to recover. Looking at 14 again, you can see that having peaked, that there's an enormous rise in the time it takes for things to be done. That then goes even further up to goodness knows where. I mean, that's what's that? That's 140 seconds, I guess, at the top there. And you've then got a period where it's gradually shutting down. And if you look at that performance compared to 15, 15 has handled that situation in a much more elegant manner and has come back quite quickly. And the live one we looked at just now was showing how that was working in practice. So let's just look at this as an example. So what we've got on the screen here is we've got the performance dashboard in the app screenshotted 4 times, one above the other, and that's enabling us to analyze the data a little bit more specifically. So depending on which button we press going across here, you can see there's a white button with number 1 on it on each screenshot. Going across there, we can click all 1, 2, 3 up to 9 or over 9. So those are seconds, those are rounded seconds, and so you can run the test, go to this screen, click the 3 button, and it's going to tell you what percentage of the users completed their functions in under 3.5 seconds. And it's also going to show you the numbers of actual users, and you can work out some stuff from it. So here we've got on this particular thing with FileMaker Server 14, we've got 80% of the users receive completion in an average of 0.18 of a second, and we've got different deployments here, 4 different deployments, showing how the figures compare. So we don't need to get into that too much, but what we can say is that we've measured FileMaker Server 15 as having an 8% improvement on speed. We've already said that it has a more refined handling of excessive load, which we think should improve the user experience. FileMaker Server 15's user resources improved, and it seems to run slightly better with a cache of 512 megabytes rather than 2 gigabytes, whereas FileMaker Server 14 seemed to require 2 gigabytes of cache to run fairly well. And maybe at that point it's worthwhile just touching on the business of cache and FileMaker Server.
Yeah, what's how big was your data set with cache on this for this server? Because 512 megabytes, but if you have a 20 gigabyte database, I mean, is really the cache need to be that small, or does it make sense to make it larger?
The rule I was told many years ago, which I'm sure must still logically apply, is the cache needs to be big enough to handle all of the parts of the database that are live at any given time. And if it's not, then it's going to mean that there's a lot more reading and writing from hard disk, and that's obviously going to slow things down. Most people, in my experience, make the considerable mistake of giving their FileMaker Server installation lots of cache when it's completely unnecessary. If you've got big data sets, then you will need more cache. But what you should do is look at FileMaker Server Admin Console, look at the statistics on the percentage of data that hit or missed the cache, and basically to get optimum performance you should be looking at that remaining at slightly below 100%. My experience is that most people just give the thing as much cache as it can have and think that's an improvement, and in reality it very rarely is. This is memory, this is random access memory that FileMaker Server is locking up to only be used by it. If it's only used by it, it can't be used by anything else, and it is only being used by FileMaker Server. It's not being used by FileMaker, it's not being used by WebDirect, it certainly isn't accessible to the operating system. And the net result is that the more RAM you put into FileMaker Server cache, the less there is available for everything else on the machine. And that's why it's really important, and frankly it's the only dynamic adjustment you've got running FileMaker Server. You know, when you've decided on the hardware specification you're going to use, about the only thing you can change is the cache, other than of course writing efficient FileMaker Solutions, of course. And the general rule is that you should use the smallest cache you can get away with, and that is always better. And interestingly, and I don't know why it is, but certainly the statistics seem to show it, interestingly it seems that FileMaker Server 15 runs a bit better with half a gig of cache than it does with 2 gig of cache, which I think is interesting.
Yeah, absolutely. Now, Nick, I know you've done testing on various types of hard drives, and I know that for the most part in our organization we will use SSD drives or solid state drives, i.e. drives with no spinning parts, but you've done some testing here, so what has your testing resulted?
In the past, we've focused mainly on spinning media machines on hard disks because it's what the vast majority of people have. A lot of people are running FileMaker on quite old equipment, and we felt it's quite a good idea to keep an eye on how things perform for those people. And we've got an interesting comparison here, because on the left we've got the chart we saw just now, which is FileMaker 15 on an SSD, solid state drive machine, and on the right we've got a hybrid. And you'll now expect that hybrid has basically got a very, very large cache on it. What it means is that the system bus is writing to the equivalent of a very small SSD, which then organizes the data and then physically writes it to the hard disk in bigger chunks. It reduces the amount of reading and writing to the spinning media by organizing it in this cache first. And what you see here is quite an interesting shape to the graph, because whereas on the left with the SSD you can see that there's a gentle curve going the whole way up. It's a pretty consistent curve until it hits the peak and it's killed. On the left here we've got a very sharp rise in the curve initially, and then it goes off a lot slower, and I'm assuming that this point here at around 140 users is where the hybrid super cache starts running out of space, and after that the amount of data that is being handled by FileMaker Server can no longer be accommodated by the cache on the hybrid, and so the second part of that graph, which is a much lower rate of increase, is where it's having to do an awful lot of reading and writing from hard disk, and that's why you have the difference there. And quite clearly the capacity of the hybrid drive, total capacity, is roughly half that of the SSD. And secondly, the period during which the performance is falling off starts a lot sooner. It starts at around about 180 users and goes on for quite a long period until the whole thing jams up. Whereas you can see that the good performance from the SSD continues pretty well until quite a short time before the thing peaks out.
Excellent. Well, that shows a definite distinction and very clearly where the cache on the hybrid drive is effective, and then where it really relies upon the rest of the spinning mechanism to try to keep pace. But that's, and it's a question of whether you want to invest in the SSDs or in the hybrid drives. And of course, if you go up on Amazon, you can rent machines or use virtual servers that have both kinds of drives. Really, they have spin drives and then they have SSDs. And they charge extra for the SSD, but in this case, it looks like it might be worth it if you have a busy server.
In my general experience, Richard, by far the best investment you can ever make in any hardware is putting SSDs in, because although I had an unfortunate experience with one from OWC which failed within a few days of installation, unless you get a bad one, I mean, they make such a difference. In most machines, most machines are between 10 and 20 times faster just by installing an SSD instead of a normal hard drive.
Exactly. Well, that wraps up our video on 14 and 15 performance comparison. If you have additional questions, feel free to email Nick at the email address here on screen. And feel free to download your own copy of the Desk Space Benchmark tool, DS Benchmark. And you can find that at his website and also at fmstartingpoint.com in our marketplace where we have some of our sample and free solutions that are available. So I appreciate it, Nick. Thank you.
Well, thank you, Richard. It's always a pleasure to talk with you. And thanks for rising so early on a Santa Clara dawn to talk with me with an 8-hour time difference.
All right. Thank you, sir.